Good morning, or good evening, or good afternoon, depending on where you are in this world and watching us. Thanks so much for joining us for the 7th edition of Programmers Week. And this year we go beyond. Programmers Week includes is represented by a multitude, more than 100 tech talks. And this week we'll have them all externally and share with you. We are delighted that you are joining us through My Connector app. And I hope you will also interact with us. Use the chat there to add questions, share your opinion, and give us feedback. There are also 2-3 emojis at the bottom, I think on the left. I hope I did it right. It's like a thumbs up, the surprise face if you learn something new, or even applause for our amazing speakers today. I'm Ioana Chiorean, a community lead and a project manager in Cognizant Softvision, and I've been with the company for, drum rolls, more than 11 years. Like a month more, but it is a bit more. So I'm still here, still rocking, and I'm very, very, very honored to moderate this track with you today. We are having some talks on .NET, and for the next few hours, we'll learn more about how to use the legacy .NET framework application with Cloud and Azure DevOps, and debugging like a pro Visual Studio. I'm definitely looking forward there to become the pro there. And the last one, but not the least, performing in JS frontend with .NET API backend application. These, again, are only for the .NET track. There are a few more in the afternoon, so I do invite you to check the agenda and get some others on your daily schedule. As I mentioned, we go beyond this year, so besides the tracks this week, which are dedicated to different technologies, we added a new day. We call it the product day, and that will be next Monday. So join us back then for talks on this subject. So let's not waste more time. I hope you have a coffee aside or a water, because we will be speaking and enjoying it, so we need to be hydrated. First on our list are our colleagues Cristi and Adrian. And I did mention a bit their sneak peek, but I'll let them be more concise and give us more details on legacy .NET Frame applications in the cloud with Azure DevOps. Hey there, how are you? How are you, Cristi? How are you, Adrian?
Hey, Ioana.
Hey, good morning.
You're good. We can't wait to start the presentation and share with you.
Let's do it then.
The findings that we have. Okay, let me share my screen. Hey, everyone. Also, welcome from our part. Welcome to a new session of Programmers Week. For those of you who may not know us yet, my name is Cristi Rusu. I'm joined with Adi, like Ioana said. We're both .NET developers in the .NET enterprise community. We've joined Cognizant Softvision about 3 years ago, almost at the same time with a couple of months difference. And like Ioana said, today we are going to talk about using legacy .NET framework application in the cloud with Azure DevOps. We'll start going over a short intro to Azure DevOps, what it is and what services it provides us. We'll then do a quick demo on Azure services, Azure DevOps, how to connect the two, how to use pipelines to create releases and to deploy your website to the cloud. And finally, we'll talk about some of the costs that are related to all of these services and some of the next steps that you can take with Azure services and Azure DevOps. Please don't forget to share any questions you might have inside the QA module, and we'll try to answer them at the end of the talk. Before we get to start with the actual introduction, we wanted to somehow set ourselves a question in the sense of why would we use legacy application with Azure? And here on the screen, you can see a couple of reasons, like maybe replacing all hardware, reducing upfront costs, offloading security concerns, ensuring you have global redundancy in case you have a really big application or you have visitors all over the world, improving scaling, and something that's probably more closer to our developers' hearts is that you will be able to transition to modern apps once your legacy application gets to the cloud. It's easier to convince the customers that, hey, we should try to do this new thing, or we should try to enhance our application and so on. And when we say legacy application, we actually mean like an old school .NET framework application, an MVC application, or a web API application that is using ADO.NET for connecting to the database. So connecting to a SQL Server database with ADO.NET. You'll see that in our demo, our example application is the actual template, MVC template that you get with Visual Studio. But besides all of these nice buzzwords and all these reasons that you can do to improve your legacy application with the cloud, there's also a personal reason of mine, because, for example, like 5 or 6 years ago, before I joined Cognizant Softvision, I was working for a customer that had their own server, so they bought their own hardware. It was hosted with a hosting provider. We had the website there. We had the database on the same server. Everything was working fine. We were only able to do backups once a month because space was limited. And if I recall correctly, all those backups were stored on an external hard drive that was connected inside the hosting environment directly to the server. So it was kind of weird, but again, the website was working just fine until one day when or better said, one night when during a hardware upgrade, we wanted to add additional hard drives to the server. Something happened to the RAID controller card, and all of a sudden the hard drives wouldn't work. The customer wasn't able to retrieve any of the data from the hard drives, and so on. And if I'm not mistaken, somewhere around 2 a.m., so 2 in the morning, a technician came to the hosting provider. They had to solder some things back to the RAID controller card, and eventually the server managed to start up again, and the customer didn't lose any of the data. They only lost all the time that it took and all the visitors that it took while the server was in downtime. And the very next morning, this type of hardware failure caused such a big stress on the customer that the very next morning, I received an email telling me that we need to switch over to cloud. We need to get rid of the server. We don't want to have any issues. We don't want to be responsible for any hardware issues. So we need to move to the cloud and let the cloud providers deal with all of that. And in that case, we went to Amazon Web Services. But by the end of this presentation, we hope that we'll be able to convince you that you don't have to wait for hardware failure to switch from using on-premise services to go to on-cloud. And with the story time behind us, I will let Adi give you an intro to Azure DevOps and talk about some of the services that are available in Azure DevOps.
Thank you, Cristi and Ioana, for the intro. Hi, everyone, again. I'm Adi, and let's see what is Azure DevOps, what are its main services, and see how they all work together in our project. So let's start with what is Azure DevOps. This is a continuous delivery platform and orchestrator from Microsoft. Maybe some of you heard of this before, or maybe you heard of it under a different name, because this was formerly known as Visual Studio Team Services, which was actually founded back in 2006. So it's a mature platform, so you can say it's the new kid on the block. And this was renamed in 2018 to Azure DevOps to better emphasize what it's actually doing. This is a software as a service platform that provides an end-to-end DevOps toolchain for developing and deploying your software. So as you can see in the picture, you have the full life cycle of an application here, from planning the app, its features, to the actual code, building, testing, deploying, and operating on it. The reason why it's a popular choice is because it provides a big flexibility by supporting any programming language. This is available on any platform, so it's available for Windows, Mac or Linux. And you can actually deploy it on any cloud providers, for Azure, AWS, or Google. So it's not just on Azure as the name would imply. Oh, here we can look at the main services that make up the platform. Let's start with the Azure boards first. This is used for planning, tracking, work items, visualization, and reporting tools. So you can look at this as an alternative to Jira. So you basically can do the same things you can do with Jira, such as have sprints, stories, backlogs, bugs, and all that stuff. But it's not that it's integrated in the same platform. The next would be the Azure pipelines. This is the CI/CD pipeline, which automatically builds, tests, and deploys the code project to make them available to others. So to give you perspective, an alternative for this would be using Jenkins or GitLab's CI/CD page. As for the Azure repos, this is a set of version control tools that you can use to manage your code. For this, you can use Git to import an existing project. So if you have an already existing repository, you can import that, or you can create a new repository from this page. And with that, you can use this just like you would use Git, so you have all the features available. The Azure test plans, these are used for testing, and it provides a test management solution for exploratory, planned, manual, and user acceptance testing. We didn't dive into this one that much, given that it's more of a QA tool. The Azure artifacts are used for artifact management, and you can also be used to consume from different feeds and public registries such as NuGet and npm. And if you want to also extend the functionality of Azure DevOps to meet your needs, you can use the marketplace, the extension marketplace, to include third parties. For example, for this we use SonarQube, but there are a lot more extensions that you can choose from. And now let's see a workflow of how our application works with all these tools. So as you can see, as a developer, you go to the Azure boards and you look to the backlog and choose a work item that you want to work on. And then you go into your IDE of choice. We are using Visual Studio, and when you're done developing that work item, you then push your code to the Azure repos. And once it's there, in order to deploy it to the develop environment, because this branch is a protected branch, you will have to create a pull request first, and only after a number of developers are done reviewing your code, then you can go ahead and trigger the build pipeline. So once you are here in the build pipeline, I won't go into much details about this one and the release pipeline because Cristi will go ahead and tell you more about this. But in both of them, a number of steps are required to be processed, and if any step will fail, then the entire build will fail. But if you are confident and optimistic that everything will succeed, then the artifacts will be published to the Azure artifacts, which then will be used inside the release pipeline. And once all the steps from the release pipeline are successful, then our new code, new application will be deployed to one of the environments that we have here. So as you can see, we have 3 environments. The first one is the develop environment. Here we deploy our code first, and after the QA team is done with testing everything and ensure that everything works. Then we are pushing the changes to the staging environment. And the same after this one is done, we are pushing the changes to the production environment. So this is the basic workflow of our application. And now Cristi will show you a demo about the Azure DevOps and Azure.
Okay, thank you. Before we get to the actual Azure DevOps part and Azure and see all the resources and the pipelines, I wanted to also give you an overview of how this is, how all of these resources are managed and configured and so on. So for example, for each environment, we decided to create a specific resource group. This allows us to separate the permissions that we set for each environment. So for example, the pipeline that is responsible with deploying the changes to develop will not have permissions to also make changes on the staging environment or to the production environment. So, and the resource groups will allow us to do this. And also because if you use resource groups, Azure has a nice feature where you can actually see the cost of each resource group. So for example, a customer would be able to see how much they had to pay for the development environment, how much for the staging environment, how much for the production environment, and so on. And here on the screen, you can see two of our resource groups, one for the development, one for the staging environment. Both of them are similar. But something that you'll notice is that because because for this demo, we wanted to reduce the cost as much as possible, we only have a key vault here, a storage account, and a web virtual machine image. So we don't have the actual web virtual machines that are running. We don't have any virtual network. We don't have the public IP address. All of those resources will be created automatically during the release pipeline. So here inside the key vault, we are storing all of our secrets like connection strings, I don't know, maybe access tokens and so on. So we don't have to hard code them inside our code or inside our pipelines. For inside the storage account, we use this just to store some of the templates that we use to create our Azure resources. And here for the virtual machine image, basically because we didn't want to recreate the same steps over and over again, like installing IIS, installing .NET framework, configuring the website, configuring the application pool, and so on. We started by using a Windows virtual machine. We installed everything that we needed on that virtual machine. We generalized the virtual machine and transformed it into a virtual machine image. And once we have that image, we can create additional virtual machines that have this particular image as a source. This way, we don't need to go through all those steps again. For the production environment, obviously the environment is different. In this case, we don't have the option of creating the resources only when we need them. So besides the key vault and the storage account, you see that we also have a public IP address, a load balancer. We have the virtual network and network interfaces. We have our SQL Server virtual machine, and we also have a virtual machine scale set. This type of resource is responsible with actually scaling our web virtual machine. For example, let's say you have a rule that says that if the CPU usage on a virtual machine goes over 75%, the virtual machine scale set will automatically create a new virtual machine, and the load balancer will know to send the request to all of those virtual machines that are created as part of this particular machine scale set. And here as well, instead of having only one virtual machine image, we have a virtual machine image definition resource and virtual machine image version. So basically, when we want to deploy changes to production, instead of going and deploying the same change to each virtual machine that's part of the scale set, we create a new virtual machine image version. So let's say if we are on version 1, we go ahead and create version 2, and then the virtual machine scale set will just automatically pick up those changes, and it will deploy those changes to all the virtual all the virtual machines without us having to do any manual work and so on. Now, we also needed another resource group, something for the agent pool. Basically, an agent is a piece of software that runs on a particular virtual machine, and that software has the ability to do all the action that I just talked about. So that agent will be able to create the resources, will be able to run your database scripts, will be able to deploy websites and so on. But for that agent to run, we also need to have a particular virtual machine so it can run on that virtual machine. And that's why we have an additional resource group here, just for that. Now, our deployment steps, because as I said, the example that we use is just a basic MVC template from Visual Studio. Our deployment steps are also fairly simple. We get the code from our repository, we restore NuGet packages, we set up SonarQube, we build our solution, we run unit test, we generate the code coverage report, we publish all the analysis to SonarQube, and at the end of the build pipeline, we publish the artifact. Once this artifact is published, a release pipeline will automatically start. And what you see here are the steps for the release pipeline that is being used for development staging. Here on the left, you can see that we are creating all of these resources. So we create the public IP address, virtual network, virtual machines used for the website and for the SQL Server. We then move on and deploy the website and deploy the database. And in our case, again, for this particular presentation, we then have a delay set up to make sure that the website is running. So maybe we can do a manual check or something like that. And once this delay passes, all of the resources that we created here on the left are being removed, again, to try and reduce the cost as much as possible. But in an actual environment, let's say where you are working with a customer for an actual company and so on, instead of having the delay here, for example, you might have a task that will run your automation test or something like that. And maybe you don't need to remove the resources. Maybe the resources will remain always online. The production release steps are a bit different. Again, we need to create a particular virtual machine where we will deploy the website. But once we deploy the website to this virtual machine, we will generalize and prepare the virtual machine to be transformed in a virtual machine image version. So once this is done, we deploy the changes to the database. We also create the image version. The virtual machine scale set will automatically pick up the new version and deploy it to all the existing virtual machines. And once again we have a delay, and then we remove all the resources that we created as part of this release step. Okay, and I think that now we can jump over to the actual website, just so you can see what we're using. I hope that you can still see my screen. This is basically just the regular MVC template that comes with Visual Studio. We only updated the title here, and then we also added a new link here that says students, where we have a table inside the SQL Server, and we are connecting to it using ADO.NET to get all the details. So again, the example is fairly simple. If we go over to Azure, you get to see all of our resource group. Maybe I can do a zoom in here. Hopefully this is visible. Here you can see all of our resource group. We have the develop, the staging, the production. We have the agent pool resource group. You can ignore the network watcher one. This is something that Azure creates for you automatically, and it doesn't cost you anything. And if you go to let's say the develop resource group, let me hide this. And here, I think I'll have to zoom out. Yep. Let's see. Okay, here you can see all the resources that we use for this particular resource group. Now, because we already did a deploy, we did one yesterday, you can see that we have multiple resources, not just the one that we talked about. We already have the virtual machine for the website. We have the SQL, actually this is the SQL Server virtual machine, but we also have the one for the website. We have all the disks, we have the virtual network, and we also have a container for our Sonar Cube. And here on the left, if you go to cost analysis, for example, and we wait just a second for it to load, or more than a second. Okay, this is where you can see all the costs that we incurred so far for this particular resource group. So just for running the develop environment, so far it cost us 30 cents, and it's forecast that it will cost us 66 cents. But here on the left, and actually let me change the dates so we can see a previous invoice, because we did multiple tests during July and August. So here we have additional data. Here you can see, for example, in August, here on the right, you can see all the resources and each resource and how much each resource cost you. So this will allow you to optimize your cost and so on. So this is a really nice feature that you get automatically with Azure, and basically the actual feature is free, but you get to pay for the resources that you use. And now if you jump over to Azure DevOps, this is what you'll probably see when you create your own organization and project. This is a project. The Programmers Week 2021 is our project. You see here that you have a summary for the project. You get to see some of the stats. You get to see the members. This is just to give you an overview of what is going on with your project. But if you want to have your own custom dashboards, you can go over to dashboards, and here you can create your own. You can add different widgets that, let's say, will help you with be more productive or will help you with your daily work. So for example, here we have all the deployments that were done to the development environment. We also get to see all the user stories and epics and so on that are in progress. You also get to see if you have any pull requests to approve and so on. You also get a wiki section. We didn't populate anything here, but this is something that's very similar to Confluence, where you can create your own analysis documentation and so on about the website. If you go over to boards, here you get to see the actual work items. This is the Jira-like feature that you have. This would be something similar to the backlog, where you can see your epics, you can see your user stories, your bugs, your tasks, and so on. And for example, if you go over to sprints, because you can split your work into sprints here as well, you get to see you have your story. This is a user story inside the sprint. And something that's different here is that the user story will stay in this column, but then you will have to create your different subtests and move them from active, resolved, closed, and so on. So for example, this is the user story that we created in preparation for this presentation to change the title and so on. And here, for example, you can go ahead and if everything is done, you can make it resolved, you can have it closed, and so on. If we would close the story, it would automatically collapse and it would look like this, just like this one. Inside the repos, I'm not going to go to every single menu items, just the ones that we consider that are important. Here, for example, in reports under branches, you get to see your main branches. We have a develop and main, and we also have a release branch. And here under pull request, right now we don't have any active pull request that needs to be resolved. But if you go to a completed one, you get to see all the pull requests that were created. For example, for what we did for testing, and this is the pull request that we did yesterday. You also get to see who was assigned to the pull request, who are the reviewers. And if you go to files, you also get to see, let me make this smaller. You also get to see the changes that were made. And similar to any other comparison tool that you get with Git and so on. You get to either see the comparison in line or side by side if you want, depending on your preferences. Once your pull request is being approved, it will be automatically merged so you don't need to actually merge it and so on, unless there are some merge conflicts. If there are merge conflicts that the tool can't automatically resolve, you will have to go ahead and fix those conflicts before merging all your changes. Before jumping over to pipelines, I would also like to show you something that Adi said. For example, if you go, this is the project settings tab, and if you go over to repositories, and here under policies, you get to set different repository policies, but we wanted to go here for branch policies. And here you can see that we activated the require minimum number of reviewers policy. This way, the tool will ensure that no one is allowed to make changes directly to the developed branch or the main branch and so on without creating a pull request and without the pull request being approved by at least 2 users. Also here in the settings, for example, again, before going over to pipelines, we can see under service connections, we can see how Azure DevOps connects to the Azure environment, because you need to come here and set connections so that Azure DevOps can create resources for you, can remove your resources and so on, and have the actual permissions. And here you can see that we created connection for production, for staging, and for the develop environment. And if you go to one and let's say click on edit, here is where you can set the resource group restriction. So you can specify that this connection is only allowed to make changes to resources that are in the production resource group. This way you have a clear separation of the permissions that are being used. And something else that we can show while we are still in project settings, here under agent pool, because I was talking about how we need agents that are, again, software that's being run on a particular virtual machine to execute all our actions, all the pipelines and so on. This is where you can set up your agents. By default, you get some pipelines, some agent pipelines from Microsoft, but in order to be able to use them, you need to contact Microsoft and ask them to unlock them for you and so on. So we didn't want to go through all of that trouble. So we just created our own agent pool. And if you go to the agent pool, this is where you can see a history of all the jobs that the agents executed. Some of them have failed, most of them succeeded. If you want, you could click on a job and it will send you to that job. You can also go to diagnostics. This is where you can see when the agent was created, when it was removed. And under settings, you can set up some things that would reduce cost. For example, in our case, we set it up so you can only create a maximum number of 2 virtual machines, so that you can't have more than 2 agents at a time. And if an agent is idling for more than half an hour, it will be deleted automatically. And that virtual machine will be decommissioned as well automatically. This is, again, a cost-saving measure that we did for this particular demo. Okay, now we can jump over back to the pipelines. So you can see here that the pipelines that we see here, these are the build pipelines, and we also have the release pipelines. For the build pipelines, again, we have a pipeline for each environment. If you go over to the develop environment, for example, again, here we have a history with all the jobs that were executed by this pipeline. If you look at the job that we did yesterday, you get to see all the details here. If you want, you can click here at the bottom on the job to see the actual logs. These are all the steps that were executed by the pipeline. And you can click on any job here to see the actual logs and everything that happened during that particular step. If you go back here under tests, you get to see the unit tests that were executed by the pipeline. If you go over to code coverage, you also get to see the code coverage. Again, because this is just a demo, we didn't spend too much time adding unit tests and so on. But you can see that it's the same code coverage used by report generator that's available here. And then here under extensions, you get to see the connection that is being made with SonarQube. And if we click on this link, it should send us to the SonarQube environment. As I mentioned, the SonarQube environment is also hosted by us in our own Azure subscription as a container. So we are not using the sonarcloud.io environment. Everything is stored in our own environment. But here you get to see all the changes. You get to see the code coverage, your unit test, if you have any issues, and so on. And if you jump back to this one, there we go. And then if you move over to the, actually, let's see, before we jump over to the releases, I also wanted to show you how the pipeline actually looks. If you go here, we are still on the develop environment pipeline. We can click on edit. And this is just a big YAML file, but the nice part about this one is that you can just click on settings, and then you can specify all the options here. And you also have information for each variable that you get to set. And some of the information that you get here, for example, for this one, you also have a link where you can learn more about this particular task in case you need it. And here you can see that our pipeline starts with a trigger, and it's also in this case it's set up to start with the develop branch. So as soon as changes reach the develop branch, the pipeline will automatically trigger. Okay, I think that we can jump over to the releases pipeline now. Once we have as we mentioned, once we have the artifact published, releases. There we go. Once we have the artifacts published, we get to the release pipeline will also start automatically. We have 3 release pipelines here as well. We have production, staging, and develop. You also get to see a history of all the releases. If you want, again, you get to see the actual pipeline, how it looks. And for example, this pipeline was executed yesterday, but we stopped it at that delayed job. This is where we canceled it to make sure that the resources don't get deleted, so we can show you our website and so on. But if you want, we could jump directly to the last step and hit deploy. And in that case, it will automatically start and it will remove all of our resources. Or if you want, you can go over to logs, and you get to see all the steps that were executed and the outcome of those steps. And if you jump back to, let's go to releases, nope, not pipelines. There, and if we hit edit on the develop release, this is where you get to configure all of your actual release pipeline. You can see here that we start with artifacts. So in this case, it's configured to automatically start with the artifact that is being created for the develop environment. Here you also have a particular trigger that you can set for continuous deployment. And in this case, the trigger is enabled, and it's basically telling that each time there's a build on the develop branch, go ahead and start this release pipeline. So once the build is done, go ahead and start this release pipeline. You can also check you can also set this as a scheduled job if you want. So you can start it on a particular day or time and so on. Let me disable that. And then you have different steps. You have different jobs, and each job can have multiple tasks. For example, this is the job that creates all of the resources that we need for the development environment. If I click here, you can see that we have multiple Azure Resource Management template tasks that go ahead and execute a specific template and create our resource environment, our resources for the environment. So here you have multiple settings. You get to specify under what resource group you want to create your resource. And here you get to specify what template and what parameters to use for that resource. You also have a section called variables. This is where you can specify your variables so you don't hard code different values inside your pipeline. Here you can see that we have an access token and it's set as a secret variable, but you also have something called variable groups. And these here are linked variables from Key Vault. So here, instead of actually going ahead and typing each variable inside the pipeline, we just connected the pipeline to our Azure Key Vault, to the development Azure Key Vault, and it automatically got all of our secrets from the Azure Key Vault. And here you can see that we have one called PW 2021 connection string. This is our connection string that's available inside. This is our connection string that's available inside our web config file, and the pipeline will automatically replace that connection string with the value presented here. So you don't have to manually hard code your connection string. You don't need to set it yourself. The pipeline will automatically set everything for you. If you go here, for example, under the deploy website job, we look at the task. And here we have file transform and variable substitution options. And if you select XML variable substitution, it will automatically replace all the variables that are available here under variables. It will replace them inside web config if it finds them there. And again, something that's really nice for this part is that you have information for every single property that you have here, and you have links where you can get additional information if you need. For the database setup, we only execute a simple command line command. We are using SQL command to just execute some SQL Server scripts. This is probably going to be dependent on how you set up your own environment and so on. For our demo, we just wanted to show you that you can execute SQL Server scripts directly from the pipeline if you need to. And as I said, next we have the delay job, and then we have a job to remove all of the resources. And here is just an Azure CLI. This is an Azure CLI task, and here we have just a bigger PowerShell script that will go ahead and remove all of the resources that we created in the initial job. And I think that I can also show you the production steps, the production release steps just really quickly. If you go here and click edit, you can see that we start with artifacts from production, and this one is a bit different. We deploy our virtual machine, we deploy the website, we have a task that generates our virtual machine image, and once that is done, we have a task that will update our virtual machine image version. We deploy our SQL Server changes, and then again, we have a delay, and we remove the resources. So that's all that I wanted to share with you from the actual Azure DevOps side. We can jump back to the presentation because now your website lives happily in the cloud, and you can think about your next step with Azure and Azure DevOps, and I will let Adi talk to you about this one.
Thanks. So once you have the app in Azure, you can do a lot more with it. You have a lot of features in Azure, and some of these features can be used for any app, but others are more specific because not every app has the same needs. So you will have to choose what you actually need. Let's start with application insights. This is a feature that's used to monitor live applications, which includes a powerful analytic tools to help you diagnose issues and understand what the users are actually doing with your app. This is something like Google Analytics. is designed to help you continuously improve the performance and usability of your application, and it can be used for apps stored in cloud or hybrid, or even for applications that are stored on-premise. The deployment slots are used when you want to deploy your code to the production environment, but you want to test it before. So you have one app instance which is always mapped to the production slot, to which you first deploy the new instance of the code. And after you are done with your testing, you can swap the two, and you have the latest code in the production. And if you later find a bug, you can just swap the two back, and you have again the previous version in production. The Azure SQL database and the Cosmos DB are both fully managed database instances, so you don't have to worry about things like upgrading, patching, backups, and all that database management, because they are automatically done by Microsoft. And Azure SQL database is always running on the latest stable version of the SQL Server and with the patched OS, but this may not be for everyone, because you might want to have a specific version of SQL Server for your application. And Cosmos DB is very nice for modern application because it has very fast response times, it's automatic, and has an instance scalability. The Azure Functions is a serverless event-driven functionality which extends your app capabilities by implementing code that is triggered by some events in your application or other applications. And the nice thing about this is that you don't have to worry about managing the infrastructure for this. You just have to worry about the actual code. The content delivery network is used when you have a user base around the globe, not just in one place. So the CDN stores cached content of your application on different servers that are closer to the users. Therefore, this is minimizing the latency. The containers, I'm guessing everyone heard about containers at this point. You bundle your application together with all the extensions, the libraries, and the configurations you need. And you can deploy your container images to Azure Container Registry or use Azure Kubernetes to manage your containers. So it's nice that Azure has support for this as well. And lastly, Azure Redis cache. If you have data that is frequently accessed, you can keep it cached in the server memory by using Redis, and this will let you read and write to it very quickly, and this will also improve the performance and scalability of your application. Now, these are just some of the functionalities that are most common, but you can have more. And now I will let Cristi talk to you about what is the cost.
Yeah, we'll jump over the cost because we don't have much time. And there's also a question from the Q&A section that I would like to answer. You get to see all the costs inside the Azure price calculator if you want. The takeaway here is that if you want to go with pay as you go, it will cost you more than if you go ahead and reserve your instances, or if you have your own licenses. And here at the end, so there was a question available in the chat. It's something along the line of if there's a way to revert to an earlier production version in case we need that. So the way we have this set up, as I mentioned, we are using the image versions inside the production environment. So anytime you want to revert to a different version, you would have to set it up in such a way so that your virtual machine scale set will know to use a different version. So for example, you can go ahead and just remove the latest version that you created, and then your scale set will automatically update all your virtual machines to use the latest version. You'll have some issues with the database. You'll need to create your own scripts to revert the database as well. But for the actual website, it's fairly easy to do that. And that's all. Thank you.
Great. Thanks, Cristi. Thanks, Adrian. And thanks for taking the questions so fast. I don't see any other ones, so I think we are good for now. Thanks so much for the demo. It was really captivating to look, and indeed time flew with this. Congrats, and see you next time with another talk.
Thank you very much.
Bye.
For the rest of the audience, see you in 10 minutes with the next talk.